Question 4. A sample of strontium ore, so an ore is a chemical that we dig from the ground, it's obviously got strontium in there, is known to contain some strontium oxide, some strontium carbonate and some impurities. So what they've done is they've taken a mass of a crucible, that's the vessel that they're going to heat it up in. The mass of the crucible and the ore is 16.11, so if I subtract those two I can work out the mass of the ore on its own. They've heated it up and they've found that the mass goes down. So let's have a look at the chemical equation. Some of the strontium carbonate in there, SrCO3, turns into strontium oxide and carbon dioxide. And carbon dioxide is a gas, so that's going to escape to the air and it's going to have some mass. That's why the mass is going down, because I'm losing some mass when this gas is made and it's escaping into the atmosphere. Use the data to calculate the mass of strontium carbonate in the original ore sample. Give your answer to the appropriate precision. Well, if I take the mass of the crucible here and the ore, and the mass of the crucible after heating, and I subtract the two, I'll work out the mass of the carbon dioxide that's made. I have to carry on until it's heated and it doesn't lose any more mass, because then I assume that all of the strontium carbonate's reacted and it's finished, the reaction's finished. So that's 14.58 at the end. It's still releasing some carbon dioxide here, but at the end 14.58, and it stays as 14.58. All the carbon dioxide's reacted. So 16.11 take away 14.58 will give me the mass of the carbon dioxide that's made. And if I can work out the number of moles, I can work out the number of moles of strontium carbonate and the mass of that. I'll show you what I mean. So 16.11 take away 14.58 is the mass of the carbon dioxide. 1.53 grams of carbon dioxide. Now I know carbon dioxide, carbon's a mass of 12, oxygen's a mass of 16, so I've got 12 add 2 16s. 44 is the mass of carbon, is the MR of carbon dioxide. Moles is mass 1.53 divided by 44, 3.48 times 10 to the minus 2 moles of carbon dioxide are made. Now in this equation, 1 mole of strontium carbonate makes 1 mole of strontium oxide and 1 mole of carbon dioxide. So 1 mole of strontium carbonate makes 1 mole of carbon dioxide in equal amounts. But I haven't got 1 mole of carbon dioxide made, I've got 3.48 times 10 to the minus 2 moles made. Therefore I must have 3.48 times 10 to the minus 2 moles of strontium carbonate. I can work out the MR of strontium carbonate, and it comes out as 147.6. Moles is mass divided by MR, so mass is moles multiplied by MR. 3.48 times 10 to the minus 2 moles multiplied by 147.6. 5.13 grams is the mass of my strontium carbonate. Each balance reading has an uncertainty of 5.00 milligrams. Remember, a milligram, to get it into grams, because we're working in grams here, so let's get this into grams. To turn milligrams into grams, a small unit value into a large unit value, I divide by 1,000. So 5 divided by 1,000 is 0.002. But I have two balance readings, one at the beginning and one at the end, and I'm subtracting the two, one from each other. So I've got two balance readings. My error is not 0.005, it's 0.005 multiplied by 2. So my error is 0.01. That's my error. So that's how far my readings could be out. I divide by the mass that I've taken. 6.26 is the mass of the ore sample. 6.26 is the mass of the ore sample. 16.11 take away the mass of the crucible, 9.85 is the mass of my ore sample. So 0.01 is the error. 6.26, sorry, how far out the readings could be. 6.26 is the value of the amount of strontium ore that I have, multiplied by 100%. 0.160% is my percentage error. The mass of the inert impurities in the sample was 347 milligrams, or 0.347 grams. To turn milligrams into grams, remember you divide by 1,000. Deduce the mass of SRO in the sample and justify any assumption made in calculating your answer. So what I've got is, I've got 6.26 is the original mass of the ore. Subtract the mass of the impurities. Subtract the mass of the strontium carbonate, because remember the ore here, 6.26 grams of ore, has got three things in it. It's got impurities, 0.347, that it tells you here. Converted this into grams by divided by 1,000. Strontium carbonate, which we've worked out is 5.13 grams, and the remainder then is strontium oxide. So if I subtract the mass of the impurities and the mass of the strontium carbonate from the original mass of the ore, it will tell me the mass of the strontium oxide that was in the original sample, 0.783 grams. Strontium metal can be extracted, that means taken out, by heating strontium oxide with aluminium metal. In this reaction, strontium vapor, so a gas, and solid aluminium oxide are formed. Write an equation for the reaction and state the role of the aluminium in the process. Explain why strontium forms a vapor but aluminium oxide is formed as a solid. So I've got strontium oxide. I know strontium oxide is SRO. It even tells me that in the question. So SRO plus aluminium. I'm going to make strontium vapor, so that's SR, and my remainder, I've got aluminium oxide. Oh, sorry, here. Justification that, any assumptions that I've made, the strontium carbonate reacts because it's heated to a constant mass. So it's stopped reacting and all of the strontium carbonate has reacted because the mass isn't changing. In other words, all the carbon dioxide's made. Equation then here, strontium oxide, aluminium is Al. How do I know that aluminium oxide is AlO2? Well, aluminium's in group 3, so it'll form 3 plus ions. Oxygen is in group 6, so it'll form 2 minus ions, so I need 2 3 pluses and 3 2 minus to balance out and leave no charge left over, and I end up with SR gas, SR vapor on its own. And then I'm going to balance it up, so I've got O3, so I need 3 SROs to make the O's balance, 3 SRs, I'll need 3 SRs, and therefore 2 ALs here. Role of aluminium, it's removing oxygen. Something that removes oxygen is a reducing agent. So this SRO has been reduced. It's lost oxygen in going from SRO to SR. So the other chemical in there is the reducing agent. It's causing this to be reduced. The other way of looking at it is that oxygen is in 2 minus oxidation state. SR must therefore be in plus 2 oxidation state. It's in group 2 after all. So it's going from plus 2 to an element on its own where it's in 0 oxidation state. It's going from plus 2 down to 0 oxidation state. It's been reduced. It's a reducing agent, is the aluminium, causing the SRO to be reduced to SR. Explanation of why this has got why this is a solid and this is a vapor. Well, this is ionic, so it's got 3 pluses and 2 minuses. It's an ionic lattice. It's got ionic bonding, whereas this is a metal on its own. It's got metallic bonding with weaker bonds. So SR is collected as vapor because Al2O3 is an ionic lattice with ionic bonding, strong ionic bonding, whereas SR is metallic with weaker metallic bonding.